Welcome to your sixth lecture. This is the last content lecture. In this lecture we're going to learn one analysis, then we're going to discuss a couple of use cases, and after, at the end, I'm going to tell you what you will need to do in your final project. But that's at the very end. So first, let's start with the beginning. Until now, we were focusing on the analysis of only two variables together. So chi-square looked at the relationship between two categorical variables. Correlation looked at the relationship between two continuous variables. One sample t-test looked at the relationship of one continuous variable and one arbitrary point. Paired sample t-test looked at the relationship of two continuous variables and comparing the means. Independent sample t-test looked at how the means of one continuous variable are different between the two groups, and ANOVA looked at the very same thing, so mean differences between three or more groups. But this relationship between the variables, so things in life, they don't usually happen in a vacuum. There are not only two factors that come together and something happens. There are usually a lot of things, and when they all come into play, then something's going on. But let's roll a little bit back. So today's the day when you will be thinking about your algebra teacher. You will thinking about this formula that you have seen in your algebra classes, in your mathematics classes multiple times. This kx plus d, kx plus b, ax plus b, or mx plus b, or whatever you learned in your country in the algebra class. Now, today, hopefully you will find out why algebra is actually useful in life. And when I say life, I don't mean to pass this course, I don't mean university, I mean actual life. So kx plus d, let's focus on this one. This is actually a linear function if you don't remember. But let's roll back. In the previous classes, we looked at the clouds of dots. In the last two classes, we were looking at the clouds of dots and we were looking at the means. So we would have a cloud of dots. Let's say a variable of our interest is on the y-axis, and then we would fit a mean, so that would be a horizontal line then, if we're looking at the variable on the y-axis, and this was what we were looking at. If you look at the chart, you will see that actually in this case, this horizontal line doesn't fit the cloud of dots very well. However, if we plot the line that fits the cloud of dots very well, this is already not the mean. And here, what this line will represent is exactly a linear function, a function where the values of y depend on the values of x. So here again, your first class, when you were trying to figure out what is dependent variable and what is independent variable, come in useful. And in the linear function, we say that x is an independent variable, and based on these values, we can define the values of y. So it can be this, but it can be a little bit more complicated, because now we're still looking at two variables, x and y, and we say x is influencing y. X is our independent variable, y is our independent variable. If we're thinking that the world is not happening in the vacuum, any phenomena is not happening in vacuum unless you're in the lab, there are multiple other x's, all of them influencing y. If we add one more x and we say there are two independent variables influencing y, we actually can still plot it graphically, and this will be a plane. But it could be that there's many more factors, and usually in reality there are many more factors. All of them, all these multiple x's, are influencing the outcome variable, the dependent variable y. So now it gets already really complicated, so I'll give you an example. Let's say a supermarket wants to predict how much I will spend when I go grocery shopping next Saturday. And let's say they know my age, they know how much I earn, they know how much I bought last weekend. They also maybe know how big I am, my complexion, so how much can I carry. And maybe they also know what weather will be on Saturday. All these factors, what is the weather, how much I bought last time, how much I earn, whether I'm male or female, and so on and so forth, all these factors will influence how much I will buy from grocery store next Saturday. And if you know all these factors, you can actually predict with defined certainty how much I will buy. Maybe if the weather is good, I will buy ice cream and my bill will be higher. Or maybe if I bought a lot last weekend, I still don't need so much food, so I will buy less. So this would be one situation. For example, if the company, the grocery store, knows that, they might send me an offer, show me an ad to nudge me into spending more or buying a specific product. So these situations, in this class, we're going to be predicting the future, be it predicting of how much I will spend next Saturday on the groceries. The same thing are done by all the companies, you know, by Amazon when they're trying to predict what you will what product you will like and what product you might buy, by Spotify thinking what song to offer you, which one will you like, by Netflix, and so on and so forth. It can be even by means of this function we can even predict whether I will get sick by the famous virus or not. Basically, in this session, we will try to learn how to predict the future, and then if you know the basic principle, the essence of how to do that, well, predicting the future is pretty cool to begin with. But if you know how the general thing, how it works, how all these companies trying to predict your behavior and then manipulate it, that will actually be useful for you in life and in your future career, and not only to pass this course. So, start clicking.